Welcome to our deep dive, everyone. Today we're going green, diving into the fascinating world of green chemistry.
Oh, it's a really exciting field. Tons of innovation happening right now.
Exactly, and we've got a whole stack of research here, ready to uncover some seriously cool, eco-driven chemistry factoids.
Absolutely. Let's dive in.
Okay, so first off, solvents. Those liquids used constantly in chemistry labs. But a lot of them are, well, not exactly eco-friendly.
Yeah, you're thinking toxic, volatile, that sort of thing.
Right. Not good for the environment, especially with the huge amounts used in industry. So what's the solution? Can we even do chemistry without these harmful solvents?
Well, that's where ionic liquids come in. They're like the superheroes of solvents.
Superheroes. Okay, I'm intrigued.
Basically, they're salts that are liquid at room temperature. And the cool part is they can be, how do I put this? Tuned for specific reaction.
Tuned. Like a musical instrument.
Sort of. You can adjust their properties depending on the reaction, like changing the ions that make them up. So they're
Mm.
super efficient and adaptable.
So it's like having a custom-made solvent for every reaction. That's incredible.
Exactly. And because they don't evaporate easily, there are fewer harmful fumes released. Good for the environment and for the chemists working with them.
Wow, I see why they're such a big deal. Are they just being used in labs, or are they out in the real world yet?
Oh no, they're already out there. Pharmaceuticals, battery technology, even extracting metals from electronic waste in a greener way.
Oh, wow. A solution for e-waste, too.
It's a really promising research area, for sure. Recovering those precious metals could be huge for resource conservation.
Amazing. Okay, let's move on to another big challenge. Plastic. It's everywhere, and it takes forever to break down.
A massive problem, absolutely. But green chemistry might have some answers. One of the most exciting is chemical depolymerization.
Depolymerization, okay.
Yeah.
Not gonna lie, that sounds a bit intimidating. Break it down for me.
Sure, it's basically reversing how plastic is made. You take a plastic bottle, break it down to its basic building blocks, the monomers.
So instead of just recycling, which doesn't always happen effectively, we could actually break it back down to raw materials.
Exactly. And then use those to make new plastic without needing more oil, a second life for plastic.
A circular plastic economy. That would be a game changer.
It really would be. And scientists are developing catalysts to break down different types of plastic more efficiently.
That's amazing news. Okay, so we've got green solvents, we're breaking down plastic. What's next?
Let's talk about catalysts. They're like the unsung heroes of chemistry.
Ah, catalysts. I remember learning about them in high school. They make reactions go faster.
Exactly. But here's the thing. A lot of them use precious metals like platinum and palladium. Expensive and often mined from sensitive environments.
So we're using up valuable resources and potentially harming the environment at the same time.
Yeah, it's a problem. That's why catalyst recycling is so important. It's like you wouldn't throw away a good tool after using it once, right? Same idea.
Makes sense.
Yeah.
So how do we recycle catalysts? Picking out tiny pieces of metal?
It's a bit more complex, but the idea is to recover and reuse those precious metals. There are some really clever techniques like using magnets to separate them or designing them so they're easier to recover.
So getting the most out of those metals, minimizing waste, and being mindful of the environment. I like it. What else is happening in green chemistry?
Let's talk about something that's truly electrifying: electrosynthesis.
Electrosynthesis, huh? Okay, I'm drawing a blank here.
It's a pretty neat approach to chemical synthesis. Instead of using harsh reagents and high temperatures, which create a lot of waste and use a ton of energy, we're using electricity to drive reactions.
Okay, wait, so like plugging a beaker into the wall and letting the electrons do the work.
It's more complex than that, but you get the idea. We use electrodes to deliver electrons to the molecules. The beauty is it can be very selective, so fewer byproducts, less waste.
A cleaner and more efficient way to make chemicals.
Exactly. And as we get more renewable energy, electrosynthesis becomes even more sustainable, like powering reactions with the sun or wind.
That's incredible. So we've talked about green solvents, breaking down plastic, recycling catalysts, and now electrifying reactions. What's next on our green chemistry adventure?
Well, how about tackling a really big one, carbon dioxide? We know it's a major player in climate change, but what if we could turn CO2 into something valuable?
Wait, seriously? Turn CO2 into something useful? How is that even possible?
That's the idea behind electrochemical CO2 reduction. We use special catalysts to transform CO2 into useful products.
Like what? Give me some examples.
Methanol, which can be used as fuel, or ethylene, a building block for plastics. We're talking about capturing CO2 emissions and turning them into valuable stuff.
Wow, this is sounding like science fiction. Is this really something we can do?
It's still early days, but the potential is huge. Imagine not just reducing CO2 emissions, but actually using them as a resource.
Okay, that would be mind-blowing. We've covered so much already. What else should we explore?
Well, there's so much more to discuss. Bio-based materials, green catalysis, we haven't even scratched the surface.
You're right. So much to unpack. Let's take a quick break to let all this awesome science sink in. We'll be right back with more mind-blowing innovations in green chemistry.
Welcome back. It's great to see you're so enthusiastic about these green chemistry innovations.
I am. It's fascinating. Before the break, we were talking about turning CO2 into fuel and stuff.
Yeah.
Seriously, groundbreaking stuff.
It really is. And it's not just theory. Scientists and companies all over the world are working on making these technologies a reality.
So we could actually see this happening in the near future.
Absolutely, the potential is huge. Imagine not just cutting CO2 emissions, but actually using them to make useful things, turning a problem into a solution.
That's the whole point of green chemistry, right? Finding solutions that are good for the planet and for us. By the way, what got you interested in this field in the first place?
Well, I've always loved chemistry, the elegance of it, understanding how molecules work. But then I realized that we need to be responsible too. We can't just keep using resources and creating waste without thinking about the consequences.
That's so true. Green chemistry is about making chemistry sustainable as well as brilliant.
That's it. Making sure chemistry helps create a healthier planet, not just solves problems.
I love that perspective. Some people might think chemistry is just about beakers and test tubes. What would you say to them?
Look around. Chemistry is everywhere. It's in the clothes we wear, the food we eat, our medicine. And like we've been talking about, it's becoming a key player in tackling some of the biggest challenges we face.
Climate change, plastic pollution, sustainable energy, you name it. Chemistry is right there on the front line finding solutions.
Absolutely. It's not just understanding the world, it's about actively shaping the future we want. And green chemistry is a powerful tool to do just that.
That brings up something I've been thinking about. We're talking about all this amazing progress, but are there any challenges or roadblocks in green chemistry?
Well, like any field, there are always challenges, especially when you're pushing the boundaries. One of the biggest is scalability.
You mean taking something that works in the lab and making it work on a large scale in industry?
Exactly. It's one thing to prove a concept in a controlled environment, but making it commercially viable, that's a whole other challenge. It has to be efficient and cost-effective if we want people to adopt it widely.
So it's not just the science, it's the economics too.
Absolutely. For green chemistry to truly succeed, it has to be sustainable both environmentally and economically. Solutions that are good for the planet and for businesses.
Makes sense. Finding that sweet spot where innovation meets practicality. Any other challenges you see?
Yeah. Public perception is a big one. There are still a lot of misconceptions about chemistry.
You mean the idea that chemistry is all about pollution and harmful chemicals?
Yeah, exactly. We need to do a better job of telling the positive story of chemistry, especially green chemistry, showing how it's helping to solve the problems people care about.
I agree. We need to change that narrative.
Yeah.
Show the positive impact chemistry can have.
It's not the villain. It's a powerful tool for positive change. The problem solver, the innovator. You could even say it's an architect of a more sustainable future.
I like that. So we've got these amazing innovations and we're working on overcoming the challenges, but what can our listeners do to support green chemistry in their own lives?
There's a lot they can do. Choosing products made with sustainable materials, supporting businesses that are environmentally responsible, even advocating for policies that support green chemistry research.
So being conscious consumers and informed citizens.
Oh, exactly. Every little action counts. If we all make an effort, we can create a future where chemistry is a force for good.
This has been so inspiring. I'm already thinking about ways I can incorporate green chemistry into my own life.
That's great to hear. And remember, it's not just about individual actions, it's about spreading the word. Talk to your friends and family about what you've learned, share these amazing innovations, and let's help change the way people think about chemistry.
I love that. Let's make green chemistry a movement, not just a scientific discipline.
Absolutely. It's about creating a sense of shared responsibility for our planet and empowering everyone to be part of the solution.
Before we wrap up this part of our deep dive, I want to circle back to something you mentioned earlier, public perception. How can we change that perception? How do we get people genuinely excited about green chemistry?
It starts with education, making chemistry accessible and relatable.
Less jargon, more real-world examples that connect with people?
Exactly. Show how chemistry is already improving lives, solving problems we all care about, cleaning up pollution, creating new energy sources, developing more sustainable everyday products.
Show that chemistry isn't some abstract concept, but a real force for good.
Right, and it's not just about telling people what we're doing, it's about involving them, making them feel like they're part of the solution.
So things like citizen science projects, community outreach, hands-on workshops.
Exactly. The more we connect people with chemistry in a tangible way, the more they'll see it as a force for positive change.
We need to make green chemistry a movement.
Absolutely. It's about creating a shared responsibility for our planet and empowering everyone to be a part of the solution.
This conversation has really opened my eyes to the potential of green chemistry. I'm feeling energized and inspired.
Me too. It's such a dynamic field, and this is just the beginning.
I can't wait to see what the future holds. But for now, we'll have to pause our deep dive here.
Don't worry, we'll be back soon for part 3, where we'll delve into even more fascinating innovations in green chemistry. Stay tuned.
And we're back for the final part of our deep dive into green chemistry. We've seen some amazing innovations already, but I have a feeling there's more.
Oh, definitely. We've barely scratched the surface. I'm excited to share some more cutting-edge developments.
Let's hear it. What other green chemistry innovations are you most excited about?
Well, one that's really caught my eye is the development of bio-based materials.
Bio-based, So are we talking about materials made from plants and stuff?
Exactly. Moving away from petroleum-based materials and exploring alternatives from nature, instead of relying on fossil fuels, we can use renewable resources.
Okay, so like what kind of bio-based materials? Any cool examples?
Lots of exciting research with plant-based polymers, for example. They can be used to create biodegradable plastics.
So plastic packaging that just breaks down naturally, no more plastic pollution.
That's the dream. And scientists are getting closer all the time. But it's not just about replacing existing materials. We're also finding completely new bio-based materials with unique properties that could be revolutionary.
Revolutionary, huh? Give me the sci-fi version.
Think self-healing materials, like they repair themselves when damaged. Or super strong, lightweight materials inspired by spider silk. Sustainable and high-performing, the best of both worlds.
Wow, that's amazing. It seems so natural to learn from nature and apply those lessons to materials.
It is. Nature has spent millions of years perfecting these designs, so why not learn from the best? Biomimicry at its finest.
Biomimicry, I love it. So besides bio-based materials, what else in green chemistry has the potential to, really change the world?
Well, green catalysis is another area I'm really enthusiastic about. We talked about recycling catalysts before, but there's so much more happening in this field.
Remind me, what's so special about green catalysis?
Well, scientists are developing catalysts that are just inherently more efficient and selective, less energy used, less waste created, which is always a good thing.
Less waste is definitely good. What else?
We're also starting to use enzymes as catalysts.
Enzymes, like the things in our bodies.
Yep, they're nature's catalysts, and they're incredibly powerful and specific.
So biomimicry again.
Exactly. By using enzymes, we can do things that would be impossible or really inefficient with traditional catalysts. It's like nature is giving us the tools for a whole new level of green chemistry.
It seems like green chemistry is not just about replacing old technologies. It's about rethinking how we do chemistry entirely.
Exactly. It's a real paradigm shift, moving away from the idea that chemistry equals pollution. Green chemistry takes a holistic approach, considering the environmental impact right from the start.
A much-needed makeover for chemistry, I'd say.
Exactly. We're not just cleaning up the mess, we're designing chemistry to be sustainable from the ground up.
This is all so inspiring. It gives me so much hope knowing that people are working on these solutions.
It is an exciting time to be in this field. So much potential to make a difference.
And it's not just up to the scientists, is it? We all have a role to play in creating a more sustainable future.
Absolutely. We can all make choices that support green chemistry. The products we buy, the businesses we support, the policies we advocate for, every action matters.
So conscious consumers, informed citizens, passionate advocates for a greener future.
That's it. Using our collective power to make sure chemistry is a force for good, helping to heal the planet, not harm it.
That's a beautiful vision. We've covered so much in this deep dive. Any final thoughts for our listeners?
Don't underestimate the power of chemistry to change the world. It's an amazing tool for solving problems and building a more sustainable future. So stay curious, ask questions, explore. You never know what amazing discoveries are out there waiting to be found.
That's great advice. Well, that wraps up this episode of The Deep Dive. Thank you so much for joining us on this journey into the world of green chemistry.
It's been my pleasure. I hope our listeners are feeling inspired.
To everyone listening, thank you for being here. Remember, chemistry is more than just beakers and test tubes. It's about finding creative solutions to the challenges we face, and green chemistry is leading the way.
Stay curious, keep exploring, and let's all work together to create a more sustainable future. Until next time.
Keep those green chemistry dreams alive. Thanks for listening.